The Acme Company manufactures widgets. The distribution of widget weights is bell-shaped, with the widget weights having a mean of 55 ounces and a standard deviation of 8 ounces. We're to use the empirical rule to answer the following questions. So I'm going to go to our empirical rule, and we have that the mean is equal to 55 and the standard deviation is 8. So if I fill out our normal distribution, here we have the mean. One standard deviation above the mean is 63. I'm simply adding 55 plus 8. Two standard deviations above the mean is 71. And three standard deviations above the mean is 79. Now if I go below the mean, 55 minus 8 gives me 47. 55 minus 2 times 8, that gives me 39. And then three standard deviations below the mean, we have 31. So we're going to use this to determine our probabilities. A says 97% of the widgets weights lie between what two numbers? So if I take a look back at our chart, we see that 97% lie within three standard deviations above and below. So we have 31 and 79. What percentage of widget weights lie between 55 and 63? So if I locate 55 and 63, notice that there is 34%. And lastly, what percentage of widget weights lie between 39 and 71? So if we look at 39 and 71, we see that it's 95%. So I would definitely suggest the use of the empirical rule chart. Okay, the next question says, Pulse rate and beats per minute were collected from a random sample of females who were non-smokers but do drink alcohol. The pulse rates before they exercise had a mean of 74.23 and a standard deviations of 11.03. The pulse rates after they ran in place for 1 minute had a mean of 126.36 and the pulse rates before they exercised, were they more consistent or less consistent than the pulse rates after they ran in place for 1 minute? So in order to answer this question, we're going to construct two normal distributions. And for our first normal distribution, the mean is 74.23 and the standard deviation is 11.03. And for our second curve, the mean is 126.36 and the standard deviation is 24.82. So I'm going to map these out. Okay, so these scales are supposed to line up. So if we look at the first one, it has a mean of 74. So that's 40, 50, 60, 70. So this is roughly the mean. And if I go three standard deviations above the mean, 74.23 plus 3 plus the standard deviation, which is 11.03. That's going to give us 107.23. So notice I'm going three standard deviations out above the mean. And if we go three standard deviations below the mean, we get 41.14. So if I actually sketch that out, here's about 70.23, and I'm guesstimating here. And then 107 is about right here. So our curve looks something like this. If we take a look at our second curve, the mean is 126.36, which is about here. And if we go one standard deviation or 3 standard deviations above the mean, we get 200.82. And if we go 3 standard deviations below the mean, we get 51.9. So I'm going to sketch that out. So our mean is about 126.36. 3 standard deviations above the mean is about 200. 3 standard deviations below is about 50. So our curve looks something like this. And if we take a look at the curves, we can see that for the pulse rates before they smoke, they seem to be more consistent. Just notice that the spread of the normal distribution is a lot smaller than the spread after they ran a minute in place. So here we have more consistency. The next one says a normal distribution has a mean of 84 and a standard deviation of 4. Find a z-score for a data value of 76. So here we have a formula. Z is equal to x minus the mean divided by the standard deviation. So in this formula, we're going to substitute x for 76 because x is our data value. We're going to substitute the mean for 84 and a standard deviation for 4. So if we plug all of this into our formula, we have 76 minus 84 divided by 4. 76 minus 84 is negative 8 divided by 4, which is negative 2. So we have a z-score of negative 2. Next, we'll match the scatter plot along with its R value. So the first things I like to do here is I like to look for the ones that are basically straight and ascending or straight and descending. So if I take a look at B, as we read B from left to right, notice that it is increasing. Our lines appear to be tight about a line. So our R value should be 0.98. If I take a look at C, notice as I read C from left to right, the graph is descending, so I know that my R value is negative. Those points appear to be close to a central line that can be drawn through, so my R value is negative 0.96. Histogram. Okay, and in the last example, it says a 1982 pager by Hans Rosendale and Samuel Shaw established a correlation between the maximum sustained surface wind speeds and the minimum sea level pressure in the central North Pacific cyclones. And we actually use the data below to test the result. So we're going to have to find the R value, the regression equation, and we're asked to the last question. The new data has arrived indicating that the minimum sea level pressure for a storm is 974 millibars. Predict the maximum sustained wind speed in knots and round to the nearest integer. So I'm going to put this data into the calculator. All right, so I'm going to first of all turn it on. I'm going to go into stat and edit. I'm going to put the minimum sea level pressure in L1. These are my X values. I'm going to put the wind speed in L2. All right, now that I have all the data in and it appears to be correct, I'm going to go back to the home screen. I'm going to go into Stat. I'm going to scroll over to Calculate, and we're going to calculate the linear regression. So notice that our R value is negative 0.921. We're asked to find the regression equation, round each value to 2 decimals. So our regression equation is y is equal to ax plus b, where a is negative 1.05x. So notice I have to put the coefficient a, which is negative 1.05. Again, we're rounding to 2 decimal places, x, plus 1,126.41. And the last part, they want us to use that to answer the last question. It says that the minimum sea level pressure for a storm is 974, and notice that the minimum sea level pressure is x. So in our equation, I'm going to store x for 974, and we're going to solve it for y. We're going to predict the maximum sustained wind speed. So y is equal to negative 1.05x plus 1,126.41. We're going to substitute x for 974. So y is equal to negative 1.05 times x, which is 974, plus 1,126.41. And if we simplify, 1.05 times 974 plus 1126.41, and we have a wind speed of 103.71.